I'm Yasin. This is Manorama.
I'm Anthony.
And I'm Ella.
And we are Group 7.
We're here today with a real figure skater. Do you want to introduce yourself?
My name's Kaylin.
Woo! And she's going to help us find out, is angular momentum real?
The figure skater will start with their arms wide, creating a larger moment of inertia. Halfway through the spin, they will close their arms, producing a moment of inertia, thereby increasing angular velocity.
In the top right corner, you will see the equations used under the assumption of conservation of angular momentum. We will be calculating inertia B under this assumption, gaining all the other values from our experiment, and calculating the theoretical inertia B using the assumptions in the tables. Inertia A will only be calculated theoretically for the purpose of this experiment. To calculate angular velocity, we position the stopwatch in the same frame as the figure skater in each trial. We use the time of the last full rotation in position A and the first full rotation in position B to minimize the small but still present effects of friction. We then converted the time taken for each cycle to an angular velocity. Position A, we approximated Kaylin's body to be made up of 4 basic cylinders. We estimated the mass of her arms and split the remaining mass of her body into 2. Using rotational inertia for cylinder and the applicable axis for each of these masses and the parallel axis theorem, we got an inertia of 0.61 kilograms meters squared. Position B, we assumed Kaylin was made up of 2 cylinders, each with a mass half of her total mass, and the radius of 0.0672 meters. This gave us an approximation of 0.442 kilograms meters squared. In this table, we have listed the period, angular velocity at each position, and the theoretical inertia at position A. For inertia B, we calculated the theoretical inertia and the inertia assuming the conservation of angular momentum equation holds true. As you can see, we were able to maintain below 10% in the percent error between the theoretical and experimental values for inertia B. Here, we compare the initial position A momentum with the final position B momentum, including the conservation and theoretical values. It is expected to be a 100% match for the assumption of conservation of angular momentum. With the theoretical, we can see some discrepancies, but it is still around 92% accurate for both cases. Considering the amount of approximations made, this is spectacular accuracy.
Based on these results, we found that angular momentum was uncertain. The values are slightly different, however, because they're within uncertainty of each other, we have determined uncertainty.
There were some limitations in our experiment, one of which being us assuming that Kaylin was made up of basic shapes.
Another is that even though the ice reduces friction, it doesn't eliminate it altogether.
A third limitation is that the figure skater could be generating external torque by pushing off the ground with her feet.
Beautiful! Make her do a cool move.
Wow.